Welcome dear students to this session. Today we are going to discuss from class 9 mathematics book chapter 10 on circle part 4. Dear students, here we will discuss about circle through 3 points, means 3 non-collinear points. You see, before going to discuss about this, let's have some pre-discussion like how many lines can be drawn through one point. As you know, we can draw many lines through a point. Here the point is O and we have drawn 4 lines here, and we can draw many more lines through O. Now let's see how many lines can be drawn through 2 points. As you know, we can draw only one line through 2 points. Here P and Q are 2 points and we can draw only one line through P and Q. Now let's discuss about this circle. So how many circles can be drawn through one point? Let's see the situation. Here P is a point and here we see that many circles have been drawn through P. So this shows that through one point we can draw many circles. Now what about 2 points? So how many circles can be drawn through 2 points? You see, this is the situation. P and Q are 2 points and here we have drawn so many circles. So we can say we can draw infinitely many circles through 2 points P and Q. Then what about the number of circles if it exceeds 2? That is, how many circles can be drawn through 3 points? Here, this is the figure, that is Q, P, R are 3 points and here one circle is drawn through it. So what is the answer? The answer is stated by this theorem. The theorem states that there is one and only one circle passing through 3 given non-collinear points. This is the answer. But how to prove it logically? Let's see. We have taken here 3 points A, B and C which are not on the same line, means 3 non-collinear points. So we can say in the given statement that A, B and C are 3 non-collinear points. Then what to prove? Here we have to prove that one circle can be drawn through A, B and C, and the second part says the circle, as you see in this figure, this circle will be the only one such circle. So to prove this, let's have some construction. Here AB and BC we can construct 2 line segments. Then we can perpendicularly bisect both the line segments, that is AB is bisected by PQ and RS is the perpendicular bisector of BC. So we can say, let's draw AB and BC and their perpendicular bisectors PQ and RS respectively. Let the bisectors intersect each other at the point O. Now let's start proof. The proof says any point on the perpendicular bisector of line segment is equidistant from its endpoints. This is one of the statement proved in chapter 7. You see, as PQ is the perpendicular bisector of AB, any point which lies on this line are equidistant from A and B. Similarly, as BC is the line segment and RS is the perpendicular bisector of it, any point lies on RS are equidistant from B and C. So this is the fact. Now let's see. O is the point of intersection of lines PQ and RS. As we in the construction we discussed that O is the intersecting point of PQ and RS. That means O lies both on PQ and RS. Now let's consider here we joined OA, OB and OC. Why? As O lies on the perpendicular bisector PQ of AB, so O is equidistant from A and B. That means OA is equal to OB. Similarly, we know that O is also lies on RS, that means the perpendicular bisector of BC. So again O is equidistant from B and C, that means OB is equal to OC. Now here we have OA is equal to OB and OB is equal to OC. So we can say that OA is equal to OB is equal to OC. So from this, what do we get? That if we take O as the center and OA as the radius and draw a circle, then it will pass through the points A, B, C. As we know that as OA, OB and OC are equal, so O is equidistant from A, B and C. So by taking O as the center and OA as the radius, if we draw a circle, it will pass through the points A, B and C. Thus, we get a circle. So by drawing this circle, we can say that a circle can be drawn through three non-collinear points A, B and C. So is this the only circle that passes through A, B and C? So to prove the uniqueness of this circle, let's have another circle that pass through ABC. If second circle exists, then there must be a second center which is something other than O. So let's have X be the center of another circle that passes through AB and C. If X is the center, then A, XA, XB and XC are the radii of the circle. So we can say that XA is equal to XB is equal to XC. If we take one pair, that is XA is equal to XB, then we can say that X is equidistant from A and B. So it lies on the perpendicular bisector of AB, that is on PQ. Similarly, as XB is equal to XC, so X is equidistant from B and C, so it must lie on the perpendicular bisector of BC, that is on RS. Now you see, PQ and RS have two common points. That is, one is O and the other is X. Do you know that two lines can intersect only at one point, not at 2 points. Two common point means two intersecting points. So it is not possible. So the condition says that if it is not possible, then what is possible? So we can say thus O and X are the same point. Means thus there exists only one circle that passes through A, B and C. Now see, from this we know that how to prove that through three non-collinear points we can draw one and only one circle. So if 3 points are given, we can construct a circle that the steps are shown in this theorem. So let's discuss how to construct a circle through three non-collinear points. As in this theorem, we have some constructions, and from which we got the center, we can draw the circle. To draw a circle, we need a center and a radius. So how did we get this radius here? If three non-collinear points are there, in this theorem, during proving this, we draw AB and BC, and perpendicular bisectors of AB and BC, and the point where these two meet, that was the center. So whenever three non-collinear points are given, we have to join them and then perpendicularly bisect each of the line segment and let the perpendicular bisectors intersect each other at a point and let it be O. So by taking that point O as the center and OA distance as the radius by the compass, if we draw a circle, that must pass through B and C also. So this is the way how to construct a circle through three non-collinear points. Another type of construction can also be solved by this: how to construct a circle through the vertices of a triangle. If vertices of a triangle are given, that means a triangle is given, then how to construct the circle that passes through the three vertices, that means how to draw the circumcenter of the circle. Now see, if ABC is a triangle, then we have three non-collinear points AB and C. So again, by drawing drawing the perpendicular bisector of BC and by drawing perpendicular bisector of AB, we can get that the perpendicular bisectors of two sides intersect each other at a point. Let it be X. So by taking X as the center, we have, as X lies on the perpendicular bisector of BC, it is equidistant from B and C. Similarly, X is equidistant from A and B. So by taking X as the center and XA as the radius, if we draw a circle, then it must pass through B and C. So thus, we can construct a circle through A, B and C, that is circumcircle of a triangle. And another problem can also be solved by this theorem: how to construct a circle through given arc. If arc is given, how to complete the circle? If an arc like this is given, we have to complete this circle. What to do? Take any 3 points here, say P, Q and R. Here we get 3 non-collinear points. Now as before, let's join PQ and QR. Then perpendicularly bisect PQ by your compass and Also perpendicularly bisect the line segment QR by your compass, and the point where these two bisectors meet, you can take that as O. By taking O as the center and OP as the radius, we can draw a circle. You will see that this arc will lie on that circle. Thus, we can complete the circle through a given arc. Now, let's have some problem to solve. Show that two circles cannot intersect each other at more than 2 points. You see, suppose we have two circles. Let one circle is S1 and another circle is S2. Here, as you see, practically we have only 2 points that two circles intersect each other. Suppose these 2 points are PQ. So we can say let's assume let the circles S1 and S2 intersect each other at P, Q and R. As these 3 points lie on the circle, then they must be non-collinear points. So this shows that P, Q and R are non-collinear points. One and only one circle can pass through these points. But here it is given S1 and S2 both pass through the points P, Q and R. So this is a contradiction. So this contradicts this implies that this contradicts the given fact that S1 and S2 circles pass through P, Q and R. So the given fact must be false. So which is false. If this is false, then what is true? That as the statement says that two circles cannot intersect at more than 2 points. So the theorem itself says that two circles cannot have more than 2 intersecting points, as through 3 non-collinear points only one circle can be drawn. Let's solve another problem. Show that a line cannot intersect a circle at more than 2 points. So let's have a circle and a line. So the circle is S and the line is L. Here, let S circle and line L meet at 3 points more than 2 means smallest is 3. So let them meet at 3 points. Say PQ, PQ and R. If PQ is there, say the line is L and here we have 3 points P, Q and R. So we can say P, Q and R lie on the line L. If we draw the perpendicular bisector of PQ, this implies the perpendicular bisectors of PQ and QR are L1 and L2 respectively. As these are perpendicular lines on the same line, this implies L1 is parallel to L2. That means these two lines will never meet. If these two lines will never meet, then there is no point of intersection. So we cannot draw a circle through PQR. This implies L1 and L2 have no common point so we cannot have a center to draw a circle through P, Q and R. But it is stated that they have more than 3 points intersecting points of circle and the line. So which contradicts the fact that the line L and the circle S have 3 common points that is intersecting points. So this shows that a line cannot intersect a circle at more than 2 points. Dear students, today we learned that a circle can be drawn through three non-collinear points, and that is the unique circle which can pass through three non-collinear points. Dear students, we also discussed about the application of this theorem for construction of a circle through three non-collinear points, that is circumcircle of a triangle, and also to complete this circle if an arc is given. I hope you understand. Today we'll end here. Thank you.